The silence of space is broken not by sound, but by the weight of its own secrets. In the darkness beyond Neptune, a faint glimmer of light appeared, an object so small and dim that only the most sensitive instruments could detect it. It was the year when humanity's telescopes had grown sharp enough to pierce the veil of infinity, and yet even they hesitated before the enigma. The object would later be named 3I Atlas, the third known interstellar wanderer to cross into the solar system. But in this first encounter, it was simply a stranger, an intruder at the gates of the Sunday. The light was fragile, like the spark of a dying ember carried across a vast ocean. Astronomers saw only data points scattered across their screens, coordinates, magnitudes, the cold mathematics of celestial detection. But behind those numbers lay a truth more profound. The universe was not sealed, and the void was not empty. Something had come here from another star. The arrival of 3I Atlas carried an emotional gravity that no equation could capture. Humanity had only recently witnessed the passage of 1I Oumuamua, with its unnerving acceleration and its shape too elongated to resemble any known comet. Then came 2I Borisov, a comet-like visitor carrying the unmistakable signs of interstellar chemistry. To encounter yet another intruder so soon was to feel the veil of cosmic isolation thinning. No longer could Earth imagine itself merely a lonely rock adrift in an indifferent void. The universe was beginning to speak, and each object was a syllable in a language we did not yet know how to read. For NASA scientists, the discovery was electrifying, but also unsettling. Every interstellar visitor carried the potential to reshape our understanding of cosmic origins. Was this shard of matter a fragment torn from a distant planetary system cast adrift after a cataclysm? Or was it something more enigmatic, a messenger born of processes humanity had never witnessed? The distinction was not trivial. A rock ejected by chance was one thing. A pattern of repeated arrivals was another, a hint that the universe might be far more crowded with fragments, relics, or even devices than expected. Telescopes tracked the object with precision, calculating its velocity and trajectory. Almost instantly, the numbers revealed an extraordinary truth. This was not a comet bound by the sun's gravity, nor a mere asteroid following the paths of planets. The trajectory was hyperbolic, stretched beyond the grasp of the solar system. Its past lay among alien stars, and its future would return it to the galactic deep. It was a traveler that would not stay. The fear came quietly. If an object could slip so easily into the solar system, how many others had passed unnoticed in centuries before telescopes existed? What if Earth had already been brushed by fragments, or worse, struck by them? The thought gnawed at researchers in hidden ways. Catastrophes often come without warning. Here was proof that the universe could deliver visitors without notice, from regions unseen. The question of impact was not theoretical. Every planetary collision recorded in craters on Earth, or scars on the Moon, was a reminder that the cosmos had teeth. But there was another fear, deeper, quieter, harder to voice. Some scientists wondered whether 3I Atlas, like Oumuamua before it, might not be wholly natural. Its brightness fluctuated in irregular rhythms, as if sunlight reflected from surfaces not entirely random. Its course, though gravitational, hinted at subtleties that raised eyebrows. NASA teams chose their words carefully, avoiding premature speculation. Still, whispers moved through the community. What if these visitors were not only geological, but technological? What if interstellar space carried artifacts, probes, or relics of civilizations we had never met? Philosophically, the intrusion was overwhelming. To see something born in a different system was to look at time itself, carried across light years like a bottled message in a cosmic ocean. The atoms composing it had once belonged to another sun, another nursery of worlds. Perhaps they had orbited a star that had long since died. Perhaps they had witnessed a civilization rise and fall, their fragments ejected by the violence of collapsing orbits. Every pebble in interstellar space is a history book, but the language is written in forces we are still learning to decipher. And so, 3I Atlas entered human awareness as more than a point of light. It became a symbol of intrusion, a reminder that the solar system was not a closed sanctuary. NASA's scientists looked upward with both excitement and unease, knowing that the universe does not deliver such mysteries without consequence. Each interstellar object was a challenge to physics, to philosophy, and to humanity's fragile sense of solitude. This was no longer the era of distant speculation about whether we were alone. The era of visitors had begun, and the arrival of 3I Atlas, faint but undeniable, marked the opening chapter of a new story, one that would blur the lines between discovery and dread, wonder and fear. The faint light that betrayed the existence of 3I Atlas was first noticed by the Asteroid Terrestrial Impact Last Alert System, a network of telescopes whose very name carried the flavor of cosmic vigilance. Designed to detect small bodies on approach to Earth, Atlas had become humanity's watchtower on the night sky, scanning the heavens for sudden flares of danger. It was not built to discover interstellar mysteries, and yet, in its nightly trawl across the firmament, it captured a flicker that would grow into one of the most puzzling revelations in recent astronomy. The date of discovery would be marked in logbooks with clinical precision, but for the astronomers at the controls, the moment was laced with the strange thrill of encountering something never expected. At first glance, it was merely another faint moving point, one more entry among the thousands of asteroids routinely catalogued. Its speed, however, raised questions. With each successive measurement, it became clear that this object was not like the others. Its arc across the sky betrayed a velocity that could not be accounted for by the gravitational pull of the Sun alone. In the long history of astronomy, such moments have often come cloaked in confusion. When Galileo first turned his telescope skyward, he too saw things that strained the boundaries of accepted knowledge: moons circling Jupiter, spots blemishing the Sun, phases on Venus. The discovery of 3I Atlas was part of this same tradition, the sky offering evidence that the universe was stranger than the prevailing models allowed. The astronomers who first tracked the object worked late into the night, running orbital calculations that revealed its extraordinary path. A closed orbit, such as those of planets and asteroids, would have tied it to the Sun's gravity. But the curve of this newcomer was open, a trajectory that declared itself hyperbolic. The mathematics was unambiguous. This body was not born of the solar system. It was an outsider, flung from the gravity well of another star, its origins buried in distances almost impossible to fathom. For NASA scientists, the confirmation was electrifying. Interstellar objects were once a matter of theory, spoken of in lectures and modeled in equations, but never truly seen. The appearance of Oumuamua in 2017 had cracked open the door, proving that such wanderers could and did enter the solar system. Borisov, discovered in 2019, made the phenomenon undeniable, displaying all the features of a comet but carrying chemistry distinct from any known in local space. And now, with 3I Atlas, the door was no longer ajar but swinging open. 3 intruders in less than a decade raised questions far larger than any one object could answer. The circumstances of its discovery carried their own quiet irony. Atlas was meant to be a sentinel against planetary disaster, an instrument of defense. Instead, it had stumbled upon something that evoked a different kind of fear. Fear not of immediate impact, but of implications. If such objects were this common, then the galaxy was alive with wandering fragments. What stories did they tell about the chaos of planetary systems, the collisions and expulsions that scattered matter across interstellar distances? And if so many wandered, how many had passed, unobserved, lost in the night before humanity had eyes sharp enough to catch them? In the days following detection, observatories across the globe turned their instruments toward the faint intruder. The Pan-STARRS survey, the European Southern Observatory, even amateur astronomers with high-powered backyard telescopes all sought to add their measurements. Collaboration intensified, data poured into shared repositories, and orbital models were refined with every additional point of light. The effort echoed earlier moments in the history of science when the community converged on the unexplained, united by both curiosity and caution. The very act of discovery carried a human weight. There is always a first night, a first astronomer, a first observation that pulls an object out of the silence of the unknown. The men and women who first recognized 3I Atlas were not simply plotting a rock across the heavens, they were tracing the outlines of a cosmic messenger. Each pixel of data carried the echo of a journey that had begun light years away, shaped by forces that predated Earth itself. For a brief moment, science and poetry overlapped. To see 3I Atlas was to see across time, to witness the relic of a story written far from the sun's domain. Like an arrow shot from an unseen bow, it had traveled across gulfs of darkness to pierce human awareness. The astronomers who logged its path may have spoken in numbers, but the undertone was reverence, even fear, for in this discovery lay the realization that the solar system was not a closed book. It was a chapter in a greater saga, one now beginning to unfold before human eyes. In the days that followed its first detection, 3I Atlas became the subject of intense scrutiny. Telescopes across the globe pivoted toward its faint shimmer, and the work of refining its trajectory began in earnest. Astronomers live and breathe by orbital mechanics. With each new data point, the path of an object can be sharpened, its story written into equations. For 3I Atlas, those equations told a tale that was at once exhilarating and unsettling. Its orbit was hyperbolic, a curve that would never close. This was not a comet tied to the sun's embrace, nor an asteroid drawn by familiar gravity. Its journey was one way into the solar system and then out again, a fleeting visitor from the dark between stars. To trace the path of such an intruder is to peel back layers of cosmic history. Orbital mechanics does not lie. The arc of motion carries within it the fingerprints of origin. Calculations revealed that 3I Atlas had entered the solar system from a direction just offset from the constellation Lyra. Its velocity, clocked at tens of kilometers per second, was far greater than anything a solar orbit could produce. It had been accelerated elsewhere, flung across interstellar space by the gravitational violence of a system not our own. For scientists at NASA's Jet Propulsion Laboratory, the implications were profound. This was matter that had been forged in another cradle, orbiting another star, perhaps once part of another planet. As the data accumulated, astronomers turned to precedent. Oumuamua, the first interstellar object detected, had also traced a hyperbolic path, slipping past Earth with disquieting speed in 2017. Borisov, arriving 2 years later, had displayed the classic features of a comet but carried within it alien isotopic ratios. Now, 3I Atlas fit the same pattern, its trajectory confirming once again that the galaxy was not still but dynamic, scattering fragments of its architecture across gulfs of space. The repetition of this theme was not comforting. 3 times in a few short years, the cosmos had delivered messengers, and each had carried its own unsettling details. NASA scientists often describe orbital calculations as a dialogue with the universe. Each adjustment of numbers narrows the uncertainty. But here, the dialogue was laced with suspicion. The hyperbolic orbit was steep, more open than any local asteroid could sustain. It traced a course that implied vast distances traveled, eons of wandering through interstellar voids. Yet the object retained brightness inconsistent with a purely ancient fragment. It gleamed as though it were fresher, more intact than one might expect of matter weathered by cosmic rays for millions of years. To reconstruct its past, astrophysicists asked, from what kind of system could it have come? A violent scattering in a young planetary nursery could have ejected it, as forming giants flung smaller bodies outward, or perhaps a catastrophic stellar death supernova or gravitational upheaval had shattered worlds and cast debris into space. Each model hinted at chaos far removed from our sun's stability. If 3I Atlas was born of such violence, then it was a survivor, a relic carrying scars from a forgotten drama written in another sky. The trajectory also raised practical concerns. Interstellar visitors pass through quickly, and opportunities to observe them are fleeting. By the time orbital solutions confirmed its hyperbolic nature, 3 Atlas was already receding. Instruments had precious little time to gather light curves, spectral fingerprints, and velocity refinements before the object would fade beyond reach. The urgency was palpable. Every night of observation was treated as if it might be the last. There was also an emotional weight carried by those who traced its orbit. To follow its curve backward was to imagine the unimaginable distances it had crossed. Somewhere in the depths of Lyra's direction lay its true birthplace, though the line of travel was blurred by eons of gravitational nudges from passing stars. The exact source would remain unknowable, hidden by the chaos of galactic tides. And yet, to plot its path was to confront the reality that the solar system was not isolated. Space is porous, and the walls of our star's domain are more like open gates than fortress walls. Visitors can arrive unbidden, and they can carry with them mysteries older than the Earth itself. Tracing the path of 3I Atlas, NASA scientists were struck by the tension between certainty and ignorance. The mathematics was exact, the orbit hyperbolic, the speed undeniable, the origin interstellar, and yet the deeper story, the why of its journey, the meaning of its arrival remained veiled. The trajectory answered one question only to open a dozen others, each pointing toward vast, unsettling possibilities. Thus, the act of tracing its path became more than a technical exercise. It was an act of recognition, a moment when humanity looked up and realized that the boundaries of the familiar sky had been breached again. The universe was not quiet, it was sending emissaries, and each one arrived with whispers that unsettled the certainties of physics and philosophy alike. Comparisons are the natural language of science. When faced with the strangeness of 3I Atlas, astronomers inevitably turned their thoughts backward to the two other interstellar wanderers that had already disturbed the tranquility of the solar system. These predecessors, Oumuamua and Borisov, had written the first chapters of an entirely new category of astronomy. By setting 3I Atlas beside them, scientists sought context, pattern, and perhaps a glimpse of meaning. Oumuamua, discovered in 2017, was the herald. Its very name, drawn from Hawaiian, meant a messenger from afar arriving first. The designation was apartment. Unlike any comet or asteroid ever seen, it carried an elongated, cigar-like, or perhaps pancake-flat shape. Most haunting of all was its peculiar acceleration as it departed, a subtle push that could not be explained by gravity alone. Normally, comets gain such acceleration by outgassing jets of sublimating ice acting like thrusters. Yet Oumuamua betrayed no such plume, no cloud of dust or water vapor, nothing to explain its motion. The debate still smolders. Was it a shard of exotic hydrogen ice, eroded invisibly, a fractal fragment of carbon-rich dust? Or as some daring voices suggested, an artifact, a probe designed by intelligence unknown. Then came Borisov in 2019, designated 2I. Unlike Oumuamua, it appeared immediately familiar, a classic comet, haloed by a luminous coma and trailing a tail. But Borisov's chemistry marked it as foreign. Its gases bore the fingerprint of formation under conditions unlike those of the solar system, enriched with carbon monoxide in ways that startled planetary scientists. It was, in essence, proof that the processes that shaped comets here also unfolded around distant suns, though with striking differences. Borisov reassured and unsettled in equal measure. It was comfortingly cometary, yet undeniably alien. With these two cases as precedent, the arrival of 3I Atlas pressed urgently on the question of whether patterns existed. Was Oumuamua a bizarre anomaly, Borisov a more conventional representative, and Atlas something in between? Or did their rapid succession suggest that interstellar debris was far more abundant than ever suspected? If 3 such objects could be discovered within a span of years, then perhaps the galaxy teemed with wanderers, fragments from the formation and destruction of planetary systems. NASA's community of researchers framed 3I Atlas within this narrative. It shared with Oumuamua the faintness, the ambiguity of shape, the refusal to fit neatly into known categories. It shared with Borisov the role of corroboration, proving that interstellar visitors were not rare once-in-a-century anomalies, but events unfolding within the lifetimes of living scientists. The contrast between the 3 painted a portrait of diversity, no single class of interstellar object, but a spectrum of forms, each carrying distinct signatures of origin. The unease lay in what this implied. If interstellar debris could take so many shapes, then the possibilities extended beyond the natural. Oumuamua's unexplained acceleration continued to cast a long shadow, and the discovery of 3I Atlas rekindled those fears. Were these truly random fragments, or could they be instruments, scouts, or relics of long-vanished civilizations? The speculation was uncomfortable, but it refused to vanish. Harvard astronomer Avi Loeb's controversial suggestion that Oumuamua might have been technological still echoed in debates, and 3I Atlas arrived like a ghost of that argument, reminding scientists that dismissing the extraordinary too quickly was dangerous. Beyond speculation, the comparison also carried emotional weight. Humanity had lived for millennia with the assumption that the night sky was eternal and still, its lights unmoving save for planets and the occasional comet. The revelation that interstellar visitors passed through shattered that illusion. The solar system was not a closed sanctuary. It was an intersection on a galactic highway, with traffic moving unseen for ages. Oumuamua, Borisov, and Atlas were simply the first that humanity had noticed. How many others had slipped through unnoticed, silent, invisible to telescopes of earlier centuries? Each discovery had altered perception. Oumuamua instilled awe laced with suspicion. Borisov provided proof that alien chemistry could be studied directly, without leaving the solar system. And 3I Atlas arrived, carrying both threads, the suspicion of strangeness and the assurance of abundance. The comparisons were not merely academic. They underscored that humanity stood at the threshold of a new discipline, interstellar archaeology, the study of relics flung across the galaxy. Yet this realization was not comforting. If visitors were this common, then the solar system was far less isolated than once imagined. Boundaries were porous, and every arrival carried not only scientific promise, but also existential unease. The comparison with its predecessors was a reminder that the universe was in motion, restless, and that Earth was but a fragile outpost in a sea filled with messengers whose stories we had only begun to decipher. From the beginning, 3I Atlas carried with it a riddle that unsettled the tidy frameworks of celestial mechanics. Its motion was not perfectly obedient to the dictates of gravity. Astronomers expect interstellar visitors to trace smooth arcs shaped by the pull of the sun, just as comets and asteroids do. Yet when the data for 3I Atlas was gathered and refined, subtle deviations emerged, accelerations too faint to be dismissed as noise, yet too consistent to ignore. These shifts echoed, in a haunting way, the behavior of Oumuamua, which had seemed to shrug off the sun's grip as though some hidden hand propelled it outward. At first, scientists searched for a natural explanation. Comets often alter their speeds when heated by the sun, jets of sublimating ice firing like thrusters in miniature. But the telescope scanning 3I Atlas failed to reveal the familiar signatures of such activity. No coma blossomed around it, no luminous tail marked its wake. The absence was damning, an object behaving like a comet but refusing to display the body of one. The rules of celestial categories blurred, and uncertainty spread through the calculations. The strangeness deepened when brightness curves were studied. As sunlight struck its surface, the reflections shifted in patterns that resisted easy interpretation. Instead of the steady rhythm one might expect from a rounded body, the object flickered in uneven pulses, as though it were rotating around an irregular or elongated form. Some models suggested a fractured shard, jagged and tumbling unpredictably. Others imagined a pancake-thin sliver, broad enough to flash when aligned just so, then vanish into shadow. Each scenario carried with it the unsettling possibility that the shape itself was driving its odd motion, catching and redirecting solar photons in ways unfamiliar to planetary science. The idea of non-gravitational acceleration has always been a point of discomfort in astronomy, because it opens doors to questions that feel uncomfortably close to speculation. Could radiation pressure alone, the gentle push of sunlight on a surface unusually thin, account for the deviations? Calculations suggested it was possible if 3I Atlas were far lighter than expected, perhaps a structure no thicker than a sail. But such a conclusion demanded imagination. Nature rarely produces such geometries, while technology could. The line between natural shard and artificial craft blurred, leaving NASA scientists with the burden of considering scenarios that straddled the edge of science fiction. At the same time, the motion of 3I Atlas challenged another assumption: stability. Objects ejected from planetary systems are expected to wander aimlessly, their velocities shaped by chaotic scattering and stellar tides. But 3I Atlas seemed to follow a course unnervingly precise, sliding through the solar system with a path that intersected Earth's neighborhood at a time almost too convenient. The statistical odds of such alignments gnawed at the minds of modelers. Randomness was always the default assumption, yet repeated improbabilities began to suggest design, or at the very least, processes that science did not yet understand. What troubled NASA researchers most was not the magnitude of the anomalies, but their persistence. The data never yielded to neat corrections. Each effort to reconcile the acceleration with familiar cometary physics strained the models, stretching assumptions until they threatened to snap. The object's refusal to behave in ordinary ways became its defining characteristic. And just as Oumuamua's strangeness had left a lingering suspicion in 2017, 3I Atlas reignited the same unease. Perhaps the universe was trying to tell a story far more complicated than the one we were prepared to hear. Within the halls of the Jet Propulsion Laboratory, discussions slipped into hushed tones. No one wanted to declare the object unnatural, not without proof, but the comparison to its predecessors was inescapable. A trio of interstellar wanderers in less than a decade, two of them defying gravitational orthodoxy, painted a picture too sharp to dismiss as coincidence. Some feared what it implied about cosmic abundance. Others feared what it might mean about intention. For the public, such subtleties were hidden in the technical language of orbital reports and observational bulletins. But within the scientific community, the whisper grew. 3I Atlas was behaving in ways that mocked classification. A comet that was not a comet. An asteroid that refused to remain still under gravity's law. A messenger that carried its secrets lightly but with deliberate persistence. And so, the enigma of its motion became more than a matter of celestial mechanics. It became a mirror, reflecting back at humanity the fragility of its assumptions. The solar system, once imagined as orderly and predictable, was proving porous and strange. Visitors arrived unbidden, and their behavior suggested rules not yet written in the textbooks. The scientists who watched 3I Atlas glide across the night sky felt both awe and unease, knowing that the mystery of its motion was only the beginning of deeper shocks yet to come. Light is the oldest messenger in the universe. Every photon carries a story, whispering across distances so vast that they collapse human imagination. When astronomers studied 3I Atlas, it was the light-reflected sunlight captured by telescopes that became the only window into its true nature. Yet the light deceived. Instead of offering clarity, it painted a portrait of contradiction, a shifting riddle that refused to settle into familiar forms. The first measurements suggested an ordinary faintness, a magnitude consistent with a small object passing quickly through the solar system. But as nights passed and the data grew, the brightness fluctuated in ways that unsettled the observers. Comets tend to brighten predictably as they near the sun, their surfaces igniting into glowing halos. Asteroids reflect sunlight with relative steadiness, their light curves shaped by rotation. 3I Atlas belonged to neither world. Its reflections pulsed irregularly, sometimes brightening sharply, sometimes dimming into near invisibility. Models were constructed to explain the rhythm. Perhaps it was tumbling chaotically, an irregular shard spinning like a fractured blade. Perhaps its surface was smooth and flat, catching sunlight in sudden flashes like a mirror tilted toward Earth. Some even proposed that the object was fragmentary, a cluster of smaller bodies drifting together, their collective light waxing and waning as they rotated in loose formation. None of these explanations satisfied fully, for each demanded assumptions about structure or material far removed from what nature usually provides. The spectra deepened the confusion. When astronomers broke the light into its component colors, searching for chemical fingerprints, they expected signatures of common ices or minerals, water vapor, carbon compounds, silicates. Instead, the readings were sparse, muted, resistant to interpretation. It was as if the surface were cloaked, either by material unfamiliar or by a geometry that denied a clear reading. In the language of light, 3I Atlas spoke in whispers, revealing too little to trust, too much to ignore. This deception of brightness echoed the earlier riddle of Oumuamua, whose thin reflections had baffled even the Hubble Space Telescope. That object had seemed at times metallic, at times dusty, its colors shifting with each attempt to measure them. 3I Atlas continued the tradition of ambiguity, and the comparison weighed heavily on those at NASA charged with interpreting the data. For in astronomy, light is law, yet here, the law seemed broken. There were moments when the brightness suggested unnatural regularity, as though flat panels or reflective surfaces had caught the sun in deliberate fashion. Some whispered of sails, thin structures designed to harness radiation pressure. Others counseled restraint, reminding colleagues that fractured shards of rock can, under certain conditions, reflect in ways that mimic design. Still, the suspicion lingered. The deception of light might not be accidental. The public, reading popular reports, often imagined telescopes seeing crisp images, photographs of distant objects. In truth, 3i Atlas was nothing more than shifting points on a screen, numbers rendered from photons collected in detectors. The deception was not in the instruments, but in the object itself, refusing to offer the clarity that numbers usually provide. For scientists accustomed to extracting certainty from faint signals, the experience was deeply unsettling. The fear beneath the science was philosophical. Light is supposed to tell the truth. It carries the past into the present with perfect fidelity. If an object hides its identity even in light, then the universe is not merely mysterious, it is actively withholding. And so, in observing 3i Atlas, astronomers were forced to admit the possibility that some stories are not meant to be read easily, that some visitors arrive cloaked in riddles, their surfaces designed by nature or by something else to mislead. In the halls of NASA, debates stretched into late hours. Was the brightness curve evidence of a natural shard, tumbling unpredictably, or was it something crafted, intentional in its deception? Each possibility carried equal weight, and each carried implications far beyond astronomy. For if nature could produce such deceptive light, then the cosmos was stranger than imagined. And if intelligence had done so, then humanity had already entered into a dialogue it did not yet recognize. Thus, the light of 3i Atlas became more than illumination. It became a veil, shimmering with half-truths, daring observers to look closer, to question harder, and to accept that even the oldest messenger in the universe can lie. As telescopes continued to track 3i Atlas, the central question pressed harder. Where had it come from? To know its origin was to anchor its meaning, yet every attempt to answer only expanded the horizon of doubt. Trajectory analysis suggested it entered the solar system from a direction near the constellation Lyra, but that only offered a compass point, not a birthplace. Over interstellar distances, even the cleanest path is blurred by encounters with invisible forces, stellar winds, galactic tides, and the faint tugs of passing stars. By the time an object like this reaches our domain, its trail is ancient, its true origin veiled in uncertainty. Some argued it was simply the product of violent scattering. Planetary systems, in their youth, are chaotic. Giant worlds form, shift orbits, and in their gravity games, countless smaller bodies are flung outward. Most drift endlessly, interstellar debris populating the dark. If 3i Atlas was such a fragment, then it was the echo of a birth pang, a shard from a planetary nursery now far away. Yet this did not settle the unease, for its structure and behavior hinted at something more than random expulsion. Others considered stellar catastrophe. Perhaps a world had been shattered in the death throes of its star, debris cast across light years. Supernova remnants are known to seed the galaxy with heavy elements. Why not also with planetary fragments? In this model, 3i Atlas might be the orphaned bone of a destroyed world, wandering through time as a relic of cosmic violence. Such an explanation carried a somber poetry. To look at it was to look at the remains of a place that no longer existed. But speculation did not stop at violence. Some began to whisper of intentionality. If the object's behavior resembled a sail catching light, could it have been designed to travel? Radiation pressure is weak but eternal. A thin enough sheet, launched long ago, could cross the galaxy with patience as its only fuel. To entertain such a thought was to step into dangerous territory, for it meant considering the possibility that 3 Atlas was not merely from somewhere else it was sent. NASA's teams avoided public speculation, but in private the debates grew pointed. The rapid succession of 3 interstellar visitors in less than a decade raised eyebrows. Was it coincidence? Or did it reveal a density of interstellar objects previously underestimated by orders of magnitude? If the galaxy was littered with such wanderers, then 3i Atlas was but one messenger in an endless stream. Yet if patterns of motion hinted at something more deliberate, then the implications stretched into realms humanity was not ready to face. Even the question of time hung over the discussion. How old was this traveler? Had it drifted for millions of years before brushing Earth's neighborhood? Or had it been set on its path more recently, perhaps in the lifetime of civilizations now vanished? Each possibility carried its own weight. If ancient, it was a fossil of cosmic history. If recent, it might imply a connection to forces or intelligences still active. Philosophically, the origin debate cut to the heart of human self-perception. If 3I Atlas was merely a fragment of stone or ice, its arrival still testified to the galaxy's restless dynamics, reminding humanity that it lived in an open system where nothing was truly isolated. If it were more than that, if it bore even the faintest trace of design, then the solar system was no longer untouched, no longer unvisited. In the end, scientists could not fix its birthplace on the star charts. The data bent under too many uncertainties, too many gravitational perturbations across too many epochs. And yet, the mystery of origin did not weaken the fear, it sharpened it. For what cannot be traced cannot be explained, and what cannot be explained demands caution. Thus 3I Atlas remained an exile, a wanderer without a known home. It carried in its silence the unsettling possibility that the galaxy was far more alive with fragments, relics, and perhaps intentions than humanity had ever dared to believe. The question of where it came from was left open, but the implications of its journey had already begun to spread unease through the halls of NASA. Velocity is not merely a measure of speed. In the language of astronomy, it is biography. How fast an object moves tells the story of how it was born, what forces shaped it, and how far it has traveled. For 3I Atlas, the numbers were disturbing from the start. Its inbound velocity was measured at over 30 kilometers per second relative to the Sun, already beyond the reach of any local orbit. But even more troubling was its excess speed, the surplus motion that could not be explained by gravitational assists or ejection from our own system. It carried with it the unmistakable signature of an origin far away, and the question gnawed: what could have launched it with such force? The simplest explanation pointed to planetary scattering. In the youth of a star system, newborn giants often migrate, their immense gravities kicking smaller bodies outward. Millions are cast into the void this way, doomed to wander. But when the models were tested against the velocity of 3I Atlas, a disquieting result emerged. Its speed was too high. Even the most violent planetary ejections tend to produce bodies with somewhat lower velocities, slowed by the drag of countless encounters. 3I Atlas seemed unnaturally quick, as though it had been thrust outward by a force beyond the usual dance of planets. Some suggested a stellar catastrophe, a dying sun collapsing into a white dwarf or neutron star, its planets shredded, their fragments flung outward like shrapnel. Such events can impart tremendous speeds, enough to explain an object like this. If true, then 3I Atlas was not just a shard of rock, but the survivor of a star's death, a fragment that had carried its velocity across light years. To look at its speed was to look at the echo of a cosmic funeral, the inertial memory of destruction long past. Others proposed more exotic origins. Could 3I Atlas have been accelerated by interactions with dark matter, slipping through regions where unseen mass tugged more fiercely than expected? Or could it have been driven by radiation pressure over eons, a thin shard gradually pushed to impossible speeds by the steady hand of starlight? Such theories blurred the boundary between natural and artificial, for while radiation can propel debris, it can also propel sails, structures built with intention. The possibility hung unspoken but present. Velocity itself might be a clue not to randomness, but to design. The direction of travel compounded the unease. Its trajectory, traced backward, did not intersect any known stellar nursery or obvious source. It seemed to come from nowhere in particular, a path too clean for something that had drifted aimlessly through the galactic tides. Random debris should bear scars of countless gravitational deflections, yet the course of 3I Atlas was smooth, as though it had been set deliberately on its line. Even small deviations, amplified across light years, should have left the trace of chaos. Instead, the motion was unnervingly precise. For NASA scientists, the speed of 3I Atlas raised not only technical puzzles but also existential ones. If the galaxy is alive with debris moving at such velocities, then Earth's place within it is precarious. Collisions with interstellar wanderers may be rare, but they are not impossible, and the energy released by such an impact would dwarf local catastrophes. Yet beyond this practical concern was a subtler dread that velocity might be a signal. Objects do not move this way by accident. If launched deliberately by physics or by hands unknown, then 3I Atlas was more than a traveler. It was a messenger, and its speed was the message. Philosophically, the enigma of velocity carried an even deeper weight. For centuries, humans measured their place in the universe by motion planets circling suns, stars, drifting across the sky. Speed has always been a measure of relative safety, a way to calculate the future. But here was an object that defied the expected patterns, an interloper carrying with it the energy of unknown origins. In its relentless motion, scientists glimpsed both the violence of the cosmos and the possibility of intention. Thus, the speed of 3I Atlas was not just a number written in orbital reports. It was a wound in the map of cosmic understanding, a reminder that velocity is not only a physical fact but also a story, and this story was one humanity had not yet learned how to read. As the data on 3I Atlas accumulated, astronomers began to focus on its shape and surface, the features most elusive yet most revealing of its nature. Every interstellar object carries with it a geometry that hints at its history, collisions, erosions, and perhaps, in the darker corners of speculation, construction. For 3I Atlas, the signals told a story that was neither clear nor comforting. The light curves, those subtle oscillations in brightness, as the object rotated, suggested something irregular, perhaps jagged. Unlike the near-spherical asteroids that populate the main belt, or the smoother, icy nuclei of comets, 3I Atlas appeared asymmetric, tumbling unpredictably. Some models rendered it as an elongated shard, a splinter from a larger body broken long ago. Others imagined a flattened form, thin like a disk, flickering as it caught and lost the sun's rays. Still others considered a cluster of fragments, gravitationally bound but loose, reflecting unevenly as they drifted together. None of these portraits felt conclusive, and yet all carried unsettling implication. Comparisons with Oumuamua deepened the mystery. That earlier object, too, had defied classification, its shape elongated beyond any asteroid seen before, its surface smooth, its rotation strange. 3I Atlas seemed to echo those features, but with differences sharp enough to prevent easy grouping. Was it coincidence that both interstellar visitors revealed such improbable geometries? Or was there a pattern emerging, one that hinted at processes the solar system had never produced? Surface composition added another layer of strangeness. The reflectivity was low, darker than expected, suggesting carbon-rich material or weathering by cosmic radiation. Yet the albedo was inconsistent. Certain angles revealed brighter flashes, as though parts of the surface were smoother or metallic. Spectroscopy refused to settle the matter. Some readings hinted at ices, others at silicate rock, but the signals were muted, as though the surface were cloaked in something unfamiliar. A coating of organic tholins, produced by eons of radiation, might explain the darkness, but not the flashes of brightness, the glittering edges that spoke of something harder, sharper, less eroded. For NASA scientists, the combination was maddening. Nature produces irregular fragments, yes, but not often ones that mimic deliberate structure. A thin shard could be natural, torn from a collision, but also could resemble a sail. A metallic glint could be mineral, but also the echo of craft. In the margins of professional papers, where speculation whispered louder than evidence, the question persisted: was 3I Atlas merely a geological relic, or was it a relic of intention? Even if natural, its shape raised troubling possibilities. If fractured, it may have come from a catastrophic collision in another star system, a shard of a shattered planet. If disk-like, it may have been the remnant of tidal disruption, stretched thin by the gravity of a passing giant. Each scenario spoke of violence, of systems tearing themselves apart. To look at 3I Atlas was to look at a survivor, a scar drifting silently through the void. Philosophically, the surface of the object became a mirror for human thought. To some, it was proof of randomness, of a cosmos where violence sculpts fragments with no meaning beyond chance. To others, it was a whisper of design, a geometry too suggestive to ignore. And in between, the surface was simply unknown, dark, flickering, deceptive, daring observers to project onto it their fears and hopes. In scientific meetings, slides of light curves and spectral graphs became the battleground. Arguments raged over whether the irregularity was within natural expectation or beyond it. Yet beneath the numbers lay a quieter truth. 3I Atlas refused to reveal itself fully. Its shape and surface, the most fundamental of features, were both familiar and alien, plausible and impossible. It was an object that seemed to exist in tension with categories, as though crafted by a universe intent on unsettling certainty. Thus 3I Atlas carried in its body the essence of the mystery, a form that would not be pinned down, a surface that both absorbed and reflected suspicion. NASA's scientists looked at its geometry not as resolution, but as provocation, a reminder that even the shape of a stone can shake the foundations of understanding when it comes from beyond the stars. Comets have always been the most familiar wanderers of the solar system, icy bodies that flare into beauty as they approach the sun, their tails streaming across the sky like cosmic banners. For centuries, they carried both terror and wonder, omens in the heavens that stirred the imagination of humanity. To planetary scientists, they are less mystical, but no less fascinating, pristine reservoirs of early solar material, preserved in cold storage. When the third interstellar visitor, 3I Atlas, was announced, many expected that it too would behave like a comet. Yet, in the observations that followed, the most troubling feature was not what it revealed, but what it withheld: the absence of a classic tail. When first detected, astronomers wondered if its designation Atlas might foreshadow another cometary display, for the survey had discovered many comets before. The anticipation grew as it drew closer to the sun. If it contained ice, even hidden beneath a crust, the heat should release gas and dust in fountains of sublimation. The coma would bloom, the tail would stretch. It should have announced itself unmistakably as a comet. Instead, the silence deepened. No coma appeared. No tail trailed in its wake. Telescopes captured only a stubborn point of light, flickering irregularly but never blossoming into the ethereal plumes that define a comet. This refusal unsettled NASA's observers. A comet that is not a comet violates expectation, and expectation is the scaffolding of science. Without it, the scaffolding trembles. Some sought natural explanations. Perhaps it was a fragment of rock with only trace volatiles. long since baked away during eons in interstellar space. Perhaps it had been heated by cosmic rays, its icy stores exhausted long before it reached the solar system. Such an object would masquerade as cometary in origin, but arrive barren, incapable of producing the familiar tale. Yet if so, then why did its brightness still fluctuate, as though something irregular were occurring on its surface? Others considered that sublimation might be happening, but in ways hidden from Earth's instruments. Jets of gas could fire from its surface, too small or too brief to generate a visible coma, but strong enough to alter its motion subtly. This possibility offered one of the few explanations for its non-gravitational acceleration, yet it, too, was unsatisfying. The absence of dust or vapor contradicted the very idea of hidden jets. Light should scatter, spectra should show traces, and still they did not. The comparison to Borisov was damning. That second interstellar visitor had behaved exactly as expected, coma bright, tail unmistakable, chemistry alien but comprehensible. Borisov had reassured scientists that nature elsewhere followed familiar rules. 3I Atlas undid that reassurance. It mocked the categories, occupying a liminal space between asteroid and comet, but conforming to neither. In scientific papers, it would be hedged with careful words like ambiguous and anomalous. In private discussions, the words were sharper, unnatural, designed, wrong. The absence of a tail became a presence of fear, for if it were not a comet, then what was it? A shard of planetary crust stripped of ice? A relic of a shattered moon? Or a structure, thin and deliberate, built to endure the journey between stars? In astronomy, absence is often as telling as presence. The lack of a tail was not emptiness but a message, one written in the silence of vapor that never appeared. Philosophically, the refusal to conform to cometary behavior carried a heavier weight. Humanity has long relied on categories to understand the world: star, planet, moon, comet, asteroid. These labels offer safety, turning the chaos of the cosmos into manageable compartments. But 3I Atlas tore at the edges of those compartments. It asked a question that categories could not answer. What if there are things between, things beyond, things that do not care for our definitions? NASA's scientists logged the data, calibrated the instruments, and wrote their reports. But behind the technical language, the silence of the missing tail remained. It was not merely a scientific puzzle. It was a reminder that the universe does not promise to be legible, that visitors can arrive cloaked not only in strangeness, but in defiance of our most basic expectations. And in that defiance lay the seed of deeper fear, the sense that perhaps 3I Atlas was not here to be understood, but to remind humanity of how much it cannot. The absence of a cometary tail might have been unsettling, but the prospect of collision was something altogether darker. When NASA's analysts first plotted the path of 3I Atlas, relief came with the confirmation that it would not strike Earth. Its hyperbolic trajectory guaranteed escape, not impact. And yet, the very fact that it had slipped into the solar system without warning, its speed immense, its direction unpredictable, forced scientists to confront a terrifying truth. What if the next one does not miss? The solar system bears scars of such encounters. The craters that pockmark the moon are silent witnesses, unweathered by atmosphere or erosion, each a record of a collision that could just as easily have struck Earth. On our own planet, scars lie hidden beneath oceans and forests. The Chicxulub crater in Mexico, born of an impact that ended the reign of the dinosaurs. The Tunguska blast of 1908, flattening forests with a force greater than the most powerful nuclear weapons. These were local projectiles, stones and comets from within the sun's grasp. What then of an interstellar body, moving at speeds far beyond local asteroids. The energy it would release on impact defies easy imagination. The calculations were chilling. A fragment only a few hundred meters across, traveling at the velocity of 3I Atlas, could release energy thousands of times greater than Earth's nuclear arsenal. Larger bodies, kilometers wide, could end civilizations, perhaps even render Earth uninhabitable. The rarity of such events was small comfort. For a danger does not cease to exist because it is rare, it only waits longer to arrive. For NASA's planetary defense teams, the fear was not hypothetical. Atlas, the survey that had spotted the object, was designed as humanity's last alert, the sentinel that might give days or weeks of warning should a body be on course for collision. But 3I Atlas revealed the weakness of such a shield. It had entered unseen until it was already within reach of our instruments. How many others had passed before, invisible in the immensity of the night? And how much warning would humanity truly have if one were aimed directly at us? There is a philosophical cruelty in such possibilities. Civilizations rise slowly, building knowledge, art, and history over millennia. Yet the cosmos, indifferent, holds the power to erase all of it in an instant with the silent strike of a stone from another star. The fear in NASA's halls was not merely of science, but of fragility, the reminder that Earth, for all its richness, is defenseless against chance. And yet, there was another layer of dread. If 3I Atlas was more than natural, if even a fraction of the speculation about design or intention held truth, then the scenario of collision carried implications beyond randomness. An interstellar probe crashing into Earth, by accident or by purpose, would not simply be a geological event. It would be a message written in catastrophe, a signal carved into the biosphere. The fear shifted from chance to agency, from statistical threat to existential confrontation. For now, the trajectory was safe. The object would glide past, a visitor rather than an executioner. But the comfort was temporary, conditional, fragile. It depended on the assumption that the next one would also miss, that the cosmos would continue to deliver only messengers and not executioners. And in that assumption lay a vulnerability no technology could erase. The spectre of collision became a quiet undertone in every discussion of 3I Atlas. It was the nightmare no one wanted to voice openly, yet it hovered behind every orbital plot, every simulation. For each hyperbolic intruder proved the same truth. The solar system is not sealed, and the universe does not ask permission before sending stones across its threshold. The only question is when the trajectory of one of these travelers will align not with escape, but with Earth itself. Thus, the fear of 3I Atlas was not only about what it was, but what it reminded us: that safety is an illusion, and that civilization endures only by the grace of chance in a cosmos where chance rules absolutely. The arrival of 3I Atlas did not occur in isolation. In less than a single decade, astronomers had witnessed 3 interstellar visitors, Oumuamua, Borisov, and now Atlas. Before 2017, not one had ever been confirmed. To encounter 3 in such quick succession seemed to mock the very idea of coincidence. For NASA scientists, the repetition raised a haunting possibility. Perhaps the galaxy was not a desert punctuated by rare wanderers, but a river, flowing with countless interstellar fragments that had always slipped past unnoticed. The numbers alone were troubling. If 3 had been detected in such a short span, then statistical inference suggested that untold thousands must be passing through the solar system every century, most too faint, too small, or too swift for detection. The solar system, once imagined as an isolated stage, now looked more like an intersection on a busy galactic thoroughfare. Every planet, every moon, even the sun itself was immersed in this silent traffic. The realization shook the foundations of astronomy's quiet assumptions. The pattern also raised deeper questions. Was the clustering of discoveries merely the result of better telescopes, more sensitive surveys, and the relentless watch of systems like Atlas and Pan-STARRS? Or was there something unusual about this moment in history, some alignment of galactic dynamics funneling debris toward our neighborhood? If the latter, then humanity was living in an era of increased exposure, a window when the stars themselves seemed to be sending emissaries more frequently. Some dared to whisper of intent. If the objects were probes, if even one among them bore the trace of design, then their arrival in succession could not be mere chance. It would suggest coordination, a sequence, perhaps even surveillance. The idea was dangerous to entertain, but it refused to vanish. Patterns always provoke the suspicion of purpose. NASA's official stance was measured. The surge in discoveries was attributed to observational improvements, the triumph of better instruments rather than the anomaly of cosmic intent. And yet, behind closed doors, the unease lingered. For the pattern, whatever its cause, had already shifted humanity's perception of itself. No longer could Earth be imagined as an untouched outpost on the galactic fringe. Instead, it was part of a network, a place through which messengers drifted, unseen for centuries but now suddenly noticed, their presence undeniable. The philosophical weight of this realization was immense. Humanity has always sought meaning in patterns, constellations in the stars, rhythms in the seasons, cycles in the lives of planets. To find a pattern in interstellar arrivals was to confront the possibility that the cosmos itself was in dialogue with us, whether by accident or design, and yet the pattern was not one of comfort. It spoke of intrusion, of vulnerability, of a universe far more crowded and restless than the textbooks had promised. In this light, 3I Atlas was not only a single object, but part of a chorus, its voice joining those of Oumuamua and Borisov. Together, they sang of a cosmos in motion, a galaxy alive with fragments, reminders that the boundaries of the solar system were porous and that Earth lived under skies forever open to intrusion. And so the fear deepened not only of what 3I Atlas was, but of what it represented. The possibility that its arrival was not unique, but a harbinger of countless others, each carrying mysteries, each carrying risks. In the halls of NASA, this recognition hardened into vigilance, for if 3 had come, more would follow. And with every arrival, the question would sharpen: what story is the galaxy trying to tell, and are we prepared to hear it? When the data of 3I Atlas refused to yield to ordinary explanations, some scientists turned toward the shadows of theory, where speculation meets the unknown. Among the most provocative ideas was that the object's peculiar behavior might be shaped by dark matter, the invisible scaffolding of the cosmos. Dark matter does not shine, does not scatter light, and yet it accounts for the majority of mass in the universe. Galaxies spin upon its unseen framework. Could it be that 3I Atlas was whispering secrets of this hidden architecture? The speculation began with its anomalies, the faint, unexplained accelerations, the irregular flicker of brightness, the refusal to conform to asteroid or cometary categories. All could, in principle, be influenced by forces not yet measured. If 3I Atlas had drifted through regions dense with dark matter, its motion might have been nudged in subtle ways. Small perturbations, imperceptible across light years, could accumulate into the deviations now observed. In this vision, the object was less a messenger itself than a vessel, carrying the fingerprints of invisible currents that flow through the galaxy. Some theorists went further. If dark matter is not uniform, but clumps into halos or filaments, then 3I Atlas might have passed through such a structure. The scars of that encounter its odd trajectory, Its deceptive light curve could be evidence written not in particles but in paths. In this way, the interstellar visitor became an accidental probe, delivering clues about phenomena humanity has never directly touched. The idea was tantalizing, but it carried dread as well. For if interstellar fragments are constantly buffeted by dark matter, then every object that enters the solar system may be shaped by forces beyond our current comprehension. To observe them is to peer into the unseen, but also to admit ignorance of the deeper scaffolding upon which galaxies are built. And ignorance breeds unease, particularly when the consequences could stretch from cosmology to existential threat. NASA's physicists debated these ideas with care. Dark matter remains a hypothesis wrapped in mathematics, observed only through its gravitational pull on stars and galaxies. To invoke it in the case of 3I Atlas was to tread on speculative ground. Yet the anomalies demanded explanation, and traditional models strained under their weight. Better, perhaps, to entertain the invisible than to force the visible into unnatural conformity. For the public, such whispers rarely reached the surface. Reports spoke of unusual properties, of difficult classification, but not of dark matter streams bending the paths of stones from other stars. Yet within scientific circles, the possibility carried quiet awe. What if each interstellar visitor were not only a fragment of another system, but also a test particle, revealing the hidden topography of the galactic web? To chart their paths might one day mean to chart the unseen skeleton of the universe itself. Philosophically, the notion deepened the enigma. Dark matter has always been the great unknown, the invisible majority of the cosmos. To imagine 3I Atlas, as marked by its hand, was to confront the unsettling thought that the universe is more ghostly than solid, more unseen than seen. The object's anomalies became less about their own mystery and more about the abyss of ignorance they revealed. And so, the whispers of dark matter joined the growing chorus of explanations, none definitive, all unsettling. Perhaps 3I Atlas was nothing more than a shard of rock behaving oddly. Perhaps it was a relic of violence, or a device, or a probe. Or perhaps it was simply the first messenger to show us that the paths of the universe are written not only by stars and planets, but also by the invisible matter that holds them all together. In this interpretation, NASA's fear was not just of 3I Atlas itself, but of what it hinted at. That reality is governed by forces we cannot see, forces that shape every visitor, every orbit, every fragile calculation of safety. The object was a riddle, yes, but also a reminder that the cosmos is built upon foundations as hidden as they are vast. The most unnerving clues of 3I Atlas lay not in its speed or shape alone, but in the tiny deviations of its orbit, imperceptible to the naked eye, yet undeniable in the mathematics. NASA's teams, along with observatories around the globe, compared thousands of data points against the models of Newton and Einstein. The predictions should have been clean. Gravity is relentless, and its equations leave little room for ambiguity. But 3I Atlas did not move as expected. The deviations were slight fractions of a second in timing, minute shifts in angle but persistent. Each recalculation confirmed what astronomers least wanted to admit. The object was not obeying gravitational law in a way they could fully explain. Non-gravitational forces were the obvious culprit. Yet the usual suspects, outgassing jets, cometary tails, or solar wind pressure, remained invisible. 3I Atlas was accelerating as if nudged by a hand that left no trace. To some, the deviations recalled the puzzles of the Pioneer anomaly, when spacecraft once strayed subtly from predicted paths until thermal radiation provided an answer. But in the case of 3I Atlas, there was no heat signature, no exhaust, no source. The analogy only deepened the unease. Spacecraft had behaved strangely because they were built things, shaped by engineering quirks. If a natural body exhibited similar anomalies, then what was it? Alternative explanations strained credibility. Some suggested uneven surface reflectivity, sunlight pushing more strongly on certain facets than others. But for the numbers to work, the geometry would need to be extraordinarily thin, almost sail-like. Others considered interaction with interplanetary dust or magnetic fields, but the forces involved were far too weak. Each possibility closed one door only to open a darker one. The gravitational anomalies were not catastrophic, but they struck at the heart of scientific certainty. Gravity is the one law the universe has always obeyed, from the orbits of planets to the dance of galaxies. To see it questioned, even at the edges, was to feel the ground tremble beneath physics itself. NASA's analysts grew cautious, almost superstitious, in how they described their findings. They spoke of residuals, non-linearities, uncertainties. Yet the truth beneath the jargon was clear. Something was pushing 3 Atlas, and they did not know what. In scientific circles, the anomaly became a quiet obsession. Could it be evidence of exotic physics, dark matter currents, quantum field effects, even hints of modified gravity? Or was it a signal of something less abstract, more deliberate? If a probe were designed to mask its propulsion, to mimic natural motion while carrying hidden intent, would it not look precisely like this, nearly gravitational, but not quite? The thought was uncomfortable, yet it shadowed every dataset. For the public, the anomalies were invisible, buried in equations too technical to capture imagination. But for those at NASA and beyond who plotted the curves, the fear was palpable. They were staring at a pattern that did not belong, a visitor that refused to bow fully to the universe's oldest law, a trajectory that suggested both precision and deviation, as though balanced between the natural and the engineered. Philosophically, the gravitational anomalies raised a haunting reflection. Humanity has long believed that nature is lawful, that the cosmos can be described in equations. To see an object defy those equations, however subtly, was to glimpse the possibility that the universe still holds secrets that cannot yet be bound by mathematics. The deviation was not just orbital, it was existential. And so, in the margins of official reports and the whispered corridors of late-night discussions, the anomalies of 3I Atlas became symbols of unease. They were not large enough to trigger alarm in the public sphere, but they were persistent enough to gnaw at confidence. The visitor had passed into the solar system as if to say, "Your laws are not complete, your certainties are fragile, and your understanding remains unfinished." The whisper that trailed behind 3I Atlas was not just of rock, ice, or gravity. It was of design. Within NASA, most scientists resisted the word, wary of speculation that could undermine credibility. Yet, the object's refusal to conform to be fully comet or fully asteroid, to obey gravity without residue, invited the question others were too cautious to voice aloud. What if it is not natural at all? Oumuamua had already cracked that door open. Its thin shape, its unexplained acceleration, its lack of dust or vapor, all had led to the controversial suggestion by Avi Loeb and others that it might be a probe, a fragment of alien technology. That claim, dismissed by many as premature, lingered nevertheless. And when 3I Atlas arrived with its own cloak of strangeness, the ghost of that speculation returned. The parallels were difficult to ignore: irregular light curves, suspicious accelerations, ambiguous chemistry. It was as if a pattern were forming, each new visitor a riddle written in the same unsettling script. In closed discussions, the fear sharpened. A natural shard of rock is not frightening, no matter how strange its path. But a technological relic, drifting across interstellar space, perhaps still functional, perhaps dormant, carries implications that shake the very idea of human solitude. What if 3I Atlas were a probe, launched long ago by a civilization now distant or extinct? What if it were designed to observe silently, to gather data, to pass unnoticed until the right eyes turned upon it? The very thought altered perspective. Suddenly, its irregular reflections looked like panels. Its trajectory seemed less random, more deliberate. Its silence on radio bands became not absence, but refusal. For NASA, the weight of such interpretation was nearly unbearable. To suggest alien origin is to invite scrutiny, derision, and the charge of sensationalism. Yet to ignore the possibility is to risk blindness. The line between fear and curiosity grew thin. The history of science holds precedents for such unease. When pulsars were first discovered, their rhythmic signals so precise and regular, the discoverers half-jokingly labeled them LGM for little green men. Only later did the natural explanation rotating neutron stars emerge. Perhaps 3I Atlas would prove the same. Strange now, mundane later. But the memory of pulsars also carried a warning. Not every pattern is natural. To leap too quickly toward comfort risks overlooking the extraordinary. If 3I Atlas were artificial, the implications radiated outward like shockwaves. Who had built it? When? How many more such objects roamed unnoticed? Was Earth being watched, or was the solar system simply one waypoint among millions? The question was not of science alone, but of philosophy, politics, even theology. Humanity had always looked outward and wondered if it was alone. Here, perhaps, was an answer, drifting silently past like a messenger no one had expected. Even if artificial, the possibilities diverged. It could be ancient wreckage, long dead, nothing more than a shell. It could be a probe, functional but indifferent, recording without interference. Or it could be something more sinister, surveillance, mapping, preparation, the silence of 3I Atlas left all these possibilities open, each unsettling in its own way. NASA's fear, then, was not of proof, but of ambiguity. For proof one can confront, debate, respond. Ambiguity gnaws forever, a splinter in the mind. The agency could catalogue 3I Atlas, track its path, publish data, but the underlying suspicion that it might be a machine, not a stone, would not vanish. It would remain, unproven but haunting, every time another faint object appeared in the sky. Philosophically, the fear deepened into reflection. Humanity has long assumed that contact, if it ever came, would be clear, a signal, a ship, a visitation, undeniable. But perhaps the universe speaks more subtly. Perhaps contact arrives not as communication but as presence, as artifacts drifting silently, indifferent to whether we recognize them. In this light, 3I Atlas was not an anomaly. It was a question. And the question it asked was simple, terrifying, and unanswerable. What if they are already here, and have been for far longer than we can know? The speculation surrounding 3I Atlas did not unfold in a vacuum. It resonated with a movement already stirring within astronomy, the search for technosignatures, traces of alien engineering rather than alien voices. In the wake of Oumuamua's controversy, projects had emerged to investigate the possibility that interstellar visitors might not be mere rocks, but relics. Chief among these was the Galileo project, a bold initiative spearheaded by Avi Loeb, which sought to study unidentified aerial phenomena and interstellar objects with the rigor of astrophysics. To many in NASA, the Galileo project was provocative, even risky. It walked a fine line between daring science and taboo speculation. Yet, the repeated arrival of interstellar objects lent it new weight. If Oumuamua had been dismissed too hastily, and if 3I Atlas now carried echoes of the same anomalies, then perhaps the idea of systematic searches for artificial relics was not so reckless after all. The fear was not only of ridicule, but of being unprepared, of ignoring what might be the most important discovery in history. Technosignature research shifted the conversation. Instead of waiting for alien civilizations to broadcast radio messages, scientists considered artifacts, probes, or engineered debris as evidence. A reflective sail drifting between stars, a shard of an ancient machine, even fragments too eroded to function, all would speak of intelligence. In this new framework, 3I Atlas became more than a puzzle of chemistry or trajectory. It became a test case, a candidate for artifact status. NASA itself had to tread carefully. Publicly, the agency emphasized natural explanations, aligning with conservative tradition, but quietly, scientists collaborated with independent initiatives, pooling data, refining models, and entertaining the possibility that something unnatural might be hidden in the stream of visitors. The line between open acknowledgement and whispered speculation grew razor thin. The echoes of history haunted the debate. Just as Galileo's telescope had once shattered complacency by revealing moons circling Jupiter, so too might these modern surveys shatter the illusion of human solitude. The Galileo project, named in his honor, sought not only to gather data, but to challenge the cultural inertia that resisted radical discovery. In the light of 3I Atlas, its mission seemed prophetic. Still, fear tempered enthusiasm, for to admit the possibility of alien artifacts is to admit that humanity's sky may already be occupied, its neighborhood already surveyed. It reframes the Earth not as an isolated cradle of life, but as one point among billions of targets, noticed perhaps long before we could notice in return. The emotional weight of this possibility was not lost on those who gazed at the faint dot of 3I Atlas through their instruments. Philosophically, the resonance with Project Galileo underscored a broader truth. Science is not only about data, but about courage. To interpret anomalies as noise is safe. To interpret them as messages is dangerous. But it may also be the path to truth. The fear surrounding 3I Atlas was not simply fear of what it was, but of what it demanded from humanity: the courage to look without flinching, to consider without retreat, to accept that the cosmos may already be speaking. Thus, in the dim corridors of NASA, the shadow of Project Galileo lengthened. What had once been dismissed as speculative gained traction, not because of proof, but because of repetition. One anomaly can be ignored. Two may be coincidence. Three, in quick succession, become a pattern, and patterns demand explanation. 3I Atlas, whether natural or not, had become a catalyst, a reminder that the universe does not yield its secrets to caution, but to those willing to risk asking forbidden questions. As the debate unfolded within NASA and beyond, a quieter current of thought began to take shape. What if 3I Atlas was not a probe in the present tense, but a relic, the scattered debris of civilizations long gone? To consider this was to enter the realm of cosmic archaeology, where each interstellar object becomes not merely a piece of rock, but a shard of history. Civilizations rise and fall on Earth. Why not among the stars? If intelligent life has ever flourished elsewhere in the galaxy, then time assures that most of it is already gone. 1 billion years is enough to erase even the greatest empire, to scatter its creations into dust. The silence humanity perceives may not be proof of absence, but the echo of extinction. And if so, then interstellar objects like 3I Atlas might be the fossils, the broken bones of a cosmic past. The idea was not fantasy alone. Human civilization has already launched thousands of probes, satellites, and fragments of technology into orbit and beyond. 1 million years from now, long after Earth is silent, Those remnants may still drift between planets and stars. Some may shatter, becoming indistinguishable from natural debris. Others may endure, their shapes eroded, but their geometry still suggestive. To an alien observer, they would be puzzles much like 3I Atlas, irregular, enigmatic, hinting at purpose without revealing it fully. To see 3I Atlas in this light was to imagine it as a tombstone of another world. Perhaps it had been cast adrift by catastrophe, an engineered fragment ejected when its creators perished. Perhaps it had been a vessel, once active, now dead and tumbling endlessly through space. Even if natural, its very journey carried memory, for the atoms that composed it were forged in stars and systems far older than our own. In this sense, every interstellar rock is a relic, whether of nature or of minds unknown. NASA's scientists entertained these possibilities cautiously, knowing how easily imagination can outrun evidence, but they also knew that science thrives not only on measurement but on interpretation. To ask whether 3I Atlas was a relic was not to claim certainty, but to open the lens wider, to admit that the universe may already hold the artifacts of its own lost civilizations. The fear here was subtler, that the galaxy is littered not with living neighbors, but with the ruins of those who came before. This possibility carried philosophical weight. To hold a fragment of alien ruin would be to confront the fragility of intelligence itself. Civilizations may be temporary by nature, sparks flaring and vanishing in cosmic night. If 3I Atlas were such a sparks left over, then humanity was not unique, it was simply next in line. The object's silence, its refusal to speak in signals or signs, could be read as the silence of extinction itself. Even the ambiguity was haunting. If we cannot tell whether 3I Atlas is natural or artificial, then how many other relics pass unnoticed, misclassified as rocks, erased by our assumptions? The act of seeing may not be enough. Interpretation becomes the true challenge. Cosmic archaeology demands humility, the willingness to admit that the stones drifting past us may be more than they appear. And so, in viewing 3I Atlas as relic, the fear deepened but shifted. It was not fear of invasion or surveillance, but of impermanence, the possibility that intelligence always ends, leaving behind only debris. Each interstellar visitor becomes then a memento mori, a reminder written not in words but in trajectories. Civilizations die, but their fragments wander on. To hold this thought was to feel both awe and dread. Awe, because the galaxy might already be a museum of ruins, waiting for us to notice. Dread, because in those ruins lies the reflection of our own future. And 3I Atlas, passing silently through the solar system, may have been one such mirror, showing not only where it came from, but where we too may one day go. As data continued to resist conventional explanations, some theorists reached further into the speculative frontier. What if 3I Atlas was not composed of ordinary matter at all? What if it carried within it something exotic, a fragment of physics beyond the standard model, a shard of reality itself, cracked loose from dimensions unseen? Among the more daring hypotheses was the notion of a quantum mirror, an object reflecting not merely light, but the hidden structure of the cosmos. Quantum mirror theories are born from the recognition that matter is not always what it seems. The quantum world is filled with particles that flicker in and out of existence, waves that collapse into form only when observed, symmetries that suggest shadow universes alongside our own. If 3I Atlas were a fragment of such strangeness, its behavior might suddenly make sense. Its irregular flickering could be interference, as if two realities overlapped. Its subtle accelerations might be nudges from fields not accounted for, echoes of higher dimensions brushing against our own. Some physicists entertain the possibility of exotic matter substances with negative mass, or materials that interact differently with gravity. If such matter were embedded in 3I Atlas, it could explain the orbital anomalies. Radiation pressure might push it in ways impossible for ordinary rock. Its surface might scatter light unpredictably, shimmering not from geometry alone but from physics operating under unfamiliar rules. The speculation carried both wonder and unease. Exotic matter has long been imagined as a tool for advanced civilizations, fuel for interstellar travel, the substance of warp drives, the skeleton of wormholes. If 3I Atlas carried even a trace of such material, it might be evidence not of natural accident but of engineering. To hold such a relic, even from a distance, would be to glimpse the building blocks of technologies far beyond human grasp. NASA's scientists rarely spoke of such ideas in public. They remained buried in technical appendices, in speculative conference side sessions, in the late-night conversations where fear and fascination merge. Yet the anomalies of 3I Atlas lent these whispers weight. The thought that an object crossing our skies might not be made entirely of ordinary atoms struck at the heart of physics itself. Philosophically, the quantum mirror idea reflected humanity's deepest suspicion that reality is layered, that the world we see is only a fraction of what exists. If 3I Atlas were such a fragment, then its very presence was a revelation. The universe is not closed, it leaks. Shards of hidden dimensions might wander as freely as stones, crossing from one layer of existence into another. The fear in this vision was not invasion nor collision, but destabilization. If fragments like 3I Atlas exist, then the universe is not governed by laws we fully understand. Our equations may describe the surface, but beneath lies an ocean of unknown physics. To glimpse that ocean through a single shard is awe-inspiring, but it also erodes the comfort of certainty. Thus 3I Atlas became, in some interpretations, not an asteroid or probe, but a quantum relic, a mirror reflecting what science has yet to comprehend. Whether natural or artificial, its behavior hinted at deeper realities, forces not accounted for, dimensions not acknowledged. And in that possibility lay the greatest fear of all, that humanity, for all its equations and instruments, is only just beginning to scratch the surface of what the universe truly island. To make sense of 3I Atlas, scientists inevitably returned to the framework that has shaped modern cosmology, Einstein's theory of relativity. Gravity, space, and time woven together in the curvature of space-time are the foundation upon which orbital mechanics is built. For more than a century, relativity has described the motions of planets, the bending of light around stars, the collapse of matter into black holes. It is the language by which the cosmos speaks. Yet 3I Atlas, subtle in its defiance, seemed to whisper that even Einstein's great equations were not the final word. The hyperbolic trajectory itself was no violation. Relativity easily describes the motion of an interstellar fragment slipping past the sun's grasp. But the small residual accelerations, the brightness anomalies, the irregular motion they gnawed at the edges of the theory's certainty. It was not that relativity was wrong, but that it seemed incomplete, as though 3I Atlas carried within it a correction term humanity has yet to write. Einstein himself often acknowledged that his masterpiece was unfinished. He dreamed of a unified theory, one that would marry gravity to quantum mechanics, explaining the smallest and largest scales in a single, elegant fabric. He never achieved it. Decades later, Stephen Hawking would continue the pursuit, seeking to reconcile black holes and entropy, space-time and information. Each attempt revealed more of the puzzle, but none closed the circle. And now, as 3I Atlas crossed the sky, its anomalies pressed upon that same unfinished gap, as if to say, "Look closer, the laws you hold sacred are only approximations." NASA's theorists entertained uncomfortable possibilities. Could the deviations in 3I Atlas's orbit hint at modifications to gravity itself? Some speculated about modified Newtonian dynamics, theories that alter gravity's behavior at very small accelerations. Others considered whether interactions with the quantum vacuum might produce subtle pushes, forces invisible yet real. Each hypothesis strained credibility, but each was consistent with a haunting truth. The universe still had surprises, and perhaps Einstein's equations were but the opening verses of a longer poem. The fear was not only scientific but philosophical. Relativity had given humanity confidence, a sense that the cosmos, though vast, was legible. To admit cracks in that framework was to admit fragility in the foundation of knowledge itself. If even Einstein's laws could not fully account for an object as small as 3I Atlas, what else lay waiting in the dark, unaccounted for, unimagined? In the quiet of late-night discussions, scientists allowed themselves to wonder, perhaps 3I Atlas was not only an object, but also a test. A natural riddle, yes, but one that pressed humanity toward the next frontier of physics. Just as the precession of Mercury's orbit had led to relativity, so too might these anomalies lead to a new theory, one uniting gravity with the quantum world, one capable of explaining the universe's hidden scaffolding. And yet, for all the potential, fear persisted. Discovery is not always gentle. New laws often reveal not comfort but fragility, reminding us that the universe is less stable than we imagined. If relativity is incomplete, then the story of space-time is not one of permanence but of evolution, and humanity lives inside a cosmos whose rules may yet change. Thus 3I Atlas became, in the eyes of some, Einstein's shadow, an object that cast doubt across the certainty of physics, reminding us that the greatest theories are provisional and that every visitor from the stars may carry not only matter and motion but also correction, demanding that we rewrite the story of reality itself. If Einstein's equations framed the mystery of 3I Atlas, then the words of Stephen Hawking cast its shadow. Hawking had long warned of the dangers of uncritical curiosity, of assuming that contact with alien intelligence would be benign. In his writings and lectures, he often reminded the public that humanity's own history is filled with encounters where the technologically advanced met the unprepared, and the result was rarely kind. If interstellar visitors were not stones but artifacts, probes, or even messengers, then their silence might not be safety. It might be caution, or worse, it might be indifference. Within NASA, these echoes were not ignored. Hawking's warning about broadcasting signals into the cosmos, about inviting attention before knowing who might be listening, loomed larger as 3 Atlas drifted silently past. The object's refusal to behave like a simple comet or asteroid left room for speculation. What if it was listening? What if it was not only a relic, but a scout? The absence of signals detected from it provided no comfort, for silence can be strategic. The unease sharpened when scientists considered the timeline. 3 interstellar visitors in just a handful of years, a pattern suggesting either abundance or intent. If abundance, then the galaxy was far more crowded with wanderers than ever imagined, some natural, perhaps some not. If intent, then humanity might already be under observation, its world catalogued not by choice, but by inevitability. Hawking's warnings took on the weight of prophecy. We may not want to meet those who find us. The fear was not invasion in the cinematic sense, no fleets of ships, no dramatic confrontation. The fear was subtler: surveillance, patience, indifference on a cosmic scale. A probe need not act to change history. Its mere existence changes everything, reframing humanity as the observed, not the observer. Even a dead probe, a fragment of technology long abandoned, would alter the way we understand our place. To find evidence of alien engineering, even in silence, would be to rewrite every philosophy, every theology, every narrative of solitude. Philosophically, Hawking's voice resonates because it reminds us of scale. Civilizations are fragile. On Earth, entire empires have risen and fallen in the span of centuries. A civilization capable of launching probes across interstellar distances would be measured in millennia, perhaps millions of years. Their motives, if they still exist at all, would be inscrutable. Their technologies would be indistinguishable from natural law itself. To encounter even the relic of such a civilization is to confront a gulf so vast that human intentions, fears, and hopes seem like the games of children by comparison. And yet, Hawking also embodied curiosity. Despite his warnings, he remained a scientist drawn to the unknown, eager to map the boundaries of black holes, to seek a theory of everything. His caution was not a call to retreat, but to recognize risk. NASA's scientists felt this duality keenly as they studied 3I Atlas. To probe too far, to announce too loudly, might invite dangers unseen. But to ignore such a visitor was to waste the rarest of opportunities, a glimpse into the deep structure of the galaxy, perhaps even into the footsteps of minds older than the Earth itself. Thus, in the strange passage of 3I Atlas, Hawking's warnings became a lens, a reminder that discovery is double-edged. It can expand understanding, but it can also expose fragility. The fear surrounding the object was not only scientific but existential, echoing Hawking's words, "If the cosmos is alive with intelligence, then humanity is not at the center of its story, but merely one observer among billions. And if probes have already arrived, then perhaps we are not observers at all, we are the observed." The fear that 3I Atlas inspired was not limited to its anomalies of speed, shape, or silence. It extended into the question of what role such objects might play in the larger story of planets and life itself. Could interstellar wanderers like this be more than messengers? Could they be actors, agents in the seeding or reshaping of worlds, carrying with them the possibility of collision not only in space but in time? The idea of panspermia life carried between stars on fragments of rock or ice has long lingered on the edge of scientific speculation. Microbes embedded in the crust of a body might, under the right conditions, survive the cold voyage through interstellar darkness. If 3I Atlas were such a carrier, then its passage through the solar system was not merely astronomical but biological, part of a hidden network of exchanges that may have shaped evolution on Earth and elsewhere. Was it absurd to imagine that the seeds of life here had once ridden on an interstellar visitor, indistinguishable from 3I Atlas itself? But darker possibilities shadowed the thought. Collisions with interstellar objects might not only create life, they might end it. The impact of a high-velocity body from beyond the solar system would carry energies far beyond local asteroids. Such a strike could reset a planet's biosphere, erasing ecosystems in an instant. In this vision, interstellar fragments are both creators and destroyers. Custodians of time who shape the destinies of worlds without intention or malice. 3I Atlas, gliding silently past, became a symbol of that duality. Life, bringer or death, bringer, possibility or annihilation. NASA's planetary scientists considered these scenarios with caution. Official reports spoke of low probabilities and uncertain mechanisms. Yet the philosophical implications hung in the air. If visitors like 3I Atlas have crossed into the solar system for billions of years, then Earth itself is a product of these encounters. The story of life may not be bounded by the sun, but by the galaxy as a whole. Each interstellar object is a thread in that tapestry, weaving together distant systems into one shared biological experiment. The thought was unsettling, for if life can be seeded so easily, then it may be common across the galaxy, thriving, dying, and spreading again in cycles far older than humanity. But if extinction can also be delivered so easily, then life is fragile everywhere, always at the mercy of collisions. 3I Atlas embodied both possibilities at once, the harbinger of creation and the spectre of erasure. Philosophically, this shifted the fear from technology to inevitability. Even if 3I Atlas was natural, its existence reminded humanity that time is written not only in centuries and millennia, but in impacts and extinctions. Civilizations may rise and fall, but the deeper rhythm is planetary. The cycle of seeding and scouring, of beginnings and endings delivered from the stars. To watch 3I Atlas pass safely by was to feel reprieve, but also to know that such reprieve is temporary. The cosmos plays a longer game, and humanity is but a recent participant. In this vision, 3I Atlas was more than a curiosity. It was a mirror, showing Earth both its origin and its possible fate. Whether fragment of chaos or relic of intent, it carried within it the reminder that worlds are never isolated. They are nodes in a vast galactic network of collisions, exchanges, and extinctions. To live under such conditions is to accept fragility not as accident but as law. Thus, the fear surrounding 3I Atlas expanded into time itself. Not only could such objects end civilizations, they may already have shaped them, long before telescopes could watch. And in their silence, they remind us that the story of life is always provisional, always subject to the next visitor whose path intersects our own. Among the more unsettling whispers in the corridors of NASA was a theoretical possibility drawn not from astronomy alone, but from particle physics and cosmology, the spectre of vacuum instability. Physicists have long debated whether our universe exists in a state of stable equilibrium or whether it rests precariously in a false vacuum, a metastable condition that could, under the right disturbance, collapse into a lower energy state. If that collapse were ever triggered, the laws of physics themselves would change, atoms would unravel, chemistry would dissolve, stars would extinguish. It would not be the end of life alone, but the end of reality as we know it. How does this tie to an interstellar wanderer like 3I Atlas? The thought, whispered more than declared, was this: such objects might not be innocent fragments. If they carried exotic matter, strange quarks, or particles stabilized under alien conditions, they could serve as seeds of instability. A collision with Earth, or even with another planetary body, might introduce conditions sufficient to nudge the vacuum into collapse. It is a scenario so extreme it borders on nightmare, yet it is rooted in equations that particle physicists cannot dismiss outright. The fear is not new. Decades ago, when particle accelerators like the Large Hadron Collider were first conceived, some worried that high-energy collisions might spawn strange matter or miniature black holes, catalysts for vacuum decay. Those fears proved unfounded, but they linger as thought experiments remind us that the universe is not guaranteed to be safe. 3I Atlas, with its anomalies and enigmas, rekindled that unease. What if it was more than rock? What if it carried within it the kind of exotic physics that could rewrite the stage upon which the cosmos itself unfolds? NASA's physicists did not indulge this speculation publicly. The very idea was too destabilizing, too apocalyptic. Yet in private circles, the connection was raised. Its faint irregularities, its refusal to behave according to familiar rules, gave just enough fuel for such speculation to take hold. For if 3I Atlas could not be explained by known matter, then perhaps it carried unknown matter, and with it, unknown risks. The philosophical implications were staggering. Humanity has always imagined the universe as permanent, eternal, a canvas upon which civilizations rise and fall. But if the universe itself can collapse, if reality is contingent on fragile balance, then no civilization is safe, not even at the scale of stars. Every visitor like 3I Atlas becomes not merely a scientific puzzle, but a reminder of that fragility, a symbol of cosmic instability. And yet, there is another side to the thought. If such exotic matter exists, and if it drifts through the galaxy in relics like 3I Atlas, then perhaps it is also a message from physics itself, a chance to study what lies beyond the standard model, to glimpse the structure of reality hidden from us until now. Danger and discovery are twins in science, inseparable. To touch the unknown is always to risk transformation. Thus 3I Atlas carried with it not only the fear of impact, nor the suspicion of technology, but the more profound dread that it might alter the very fabric of existence. Even in silence, even as it passed harmlessly through, it forced humanity to confront the possibility that the laws of the universe are provisional, fragile, and that in the vastness of space, every shard drifting between stars could be both messenger and executioner. As 3I Atlas slipped further into study, a new thread of speculation emerged, one that carried both wonder and dread. Could such an object be more than a fragment of matter? Could it be a messenger between worlds, or even between universes? The idea, once confined to the most speculative corners of theoretical physics, now gained a foothold in late-night discussions. What if 3I Atlas was a trace of the multiverse? The multiverse hypothesis proposes that our cosmos is not singular, but one of many, each with its own physical laws, its own constants, perhaps even its own dimensions of time and space. If universes are born like bubbles in a vast cosmic foam, then borders between them may sometimes leak, collide, or overlap. And what if 3I Atlas was evidence of such leakage, a shard from another cosmos, wandering into ours across the boundary of reality? Its anomalies suddenly took on a different meaning. The irregular brightness, the unexplained accelerations, the resistance to classification, all could be hints of physics shaped not by our universe's laws, but by another's. Perhaps its matter was tuned to constants alien to our own, surviving only as a ghost when transposed here. Perhaps its trajectory, so smooth and improbable, was less a natural orbit than a scar left by crossing between realms. NASA's physicists, trained in caution, rarely spoke such ideas in official reports. Yet the multiverse had already entered mainstream physics through the theory of cosmic inflation, which predicts eternal spawning of new universes. If that framework held, then inter-universal debris was not impossible. And if not impossible, then what if 3I Atlas was exactly that, a fragment of somewhere else, wandering across the threshold to remind us that even reality has borders? The philosophical implications were staggering. To imagine 3I Atlas as a visitor from another universe was to dissolve the last barrier of human solitude. No longer would the cosmos be merely vast in scale, it would be vast in kind. Our laws of physics would be revealed not as universal truths, but as provincial rules governing only this bubble among many. The object became less a rock than a symbol, proof that existence is layered, that our universe is not alone. But such speculation carried fear as well. If debris can cross from one universe into another, then what else might follow? What if boundaries are not fixed but fragile, vulnerable to rupture? A shard drifting across is wonder, a torrent would be catastrophe. The thought of universes colliding, their laws entangling, was too immense to contemplate for long. 3I Atlas, in this light, was both marvel and omen. For some, the idea was liberating. It meant humanity's search for meaning need not end in silence. For others, it was chilling. If the multiverse exists, then our place within it is even smaller than imagined. our survival even more contingent. 3I Atlas became, in this speculation, not a comet or a shard, but a doorway glimpsed for an instant, a reminder that beyond our stars may lie not only other worlds, but other realities. And so the fear grew layered. Was 3I Atlas a rock, a probe, a relic, a shard of exotic matter, or was it a fragment from another universe entirely, drifting across the threshold like a message in a bottle cast from shores we cannot see? Whatever the truth, the question was the same. How fragile is the barrier between what we know and what we cannot yet imagine? The enigma of 3I Atlas also awakened a question that reached into the heart of modern cosmology. Could its presence be linked, however faintly, to the mystery of cosmic acceleration, the phenomenon humanity names dark energy? For decades, astronomers have known that the universe is not slowing down, as gravity would suggest, but expanding faster and faster, as though driven by some hidden hand. Dark energy is the placeholder term, a name given to ignorance. Might 3I Atlas, strange in its path and stubborn in its anomalies, be a fragmentary clue? The idea emerged in whispers among theorists who noticed the timing. Interstellar objects arrive unbound by solar gravity, their motions shaped by forces acting across the galaxy. If the universe itself is expanding at accelerating rates, then every wanderer carries within it the imprint of that acceleration. Could the small deviations in 3I Atlas's trajectory be less about outgassing or surface geometry, and more about the influence of an energy field that pervades all of space? Some dared to speculate that these visitors might serve as natural test particles, moving not only through stellar gravity but also through the invisible currents of dark energy. If so, then careful observation of their paths could offer data no telescope could otherwise provide. Instead of being anomalies, 3I Atlas's subtle deviations might be evident signatures of cosmic acceleration written into the course of a single shard drifting across the solar system. But the thought carried deeper unease. Dark energy is not gentle. If it drives the universe's expansion, it is also the force that will dictate its fate, whether in a big freeze, where galaxies recede into eternal silence, or in a big rip, where space itself is torn apart. To imagine 3I Atlas as a messenger of this energy was to confront the reality that even stones from the stars may carry tidings of our ultimate end. Philosophically, the link to dark energy transformed the object from a local anomaly into a cosmic symbol. It was no longer just a fragment from another star, but a reminder that every corner of the universe is subject to forces beyond comprehension. Its silence, its strangeness, its refusal to conform all could be interpreted as the quiet voice of dark energy, whispering that the cosmos is not stable, not safe, but driven by something unseen. Within NASA, such discussions were conducted carefully. No one could claim direct evidence. The deviations in orbit could just as easily be explained by surface irregularities. Yet the connection was irresistible. Interstellar objects may be the only tangible samples of a universe shaped by dark energy, arriving uninvited into our domain. They may be both visitors and teachers, offering in their motion a hint of the force that defines everything. And so, 3I Atlas became entwined with the greatest mystery of all. If dark energy is the hand that writes the fate of galaxies, then perhaps these wanderers are its pen strokes, tiny marks that reveal the larger pattern. The fear then was not only of what 3I Atlas was, but of what it represented. That every visitor from the stars is also a reminder that the universe itself is accelerating toward a destiny no civilization can escape. Through months of scrutiny, NASA turned not only its telescopes but also its ears toward 3I Atlas. The great radio observatories Arecibo before its collapse, the Green Bank Telescope, and the Allen Telescope Array were enlisted to listen for signals. If the object were artificial, if it were transmitting even the faintest whisper across the void, the instruments would hear, yet the outcome was silence, deep and unbroken. At first, that silence reassured. A rock does not speak, a comet does not broadcast, and an absence of signal suggested natural origin. But for those who had studied the history of SETI, the search for extraterrestrial intelligence silence was never so simple. It could mean disinterest, it could mean camouflage, it could mean communication in frequencies humanity does not yet understand. Silence itself can be strategic. The telescopes strained at every wavelength available, scouring for regular pulses, narrow-band tones, or bursts of structured noise. Nothing came. The absence of signal was catalogued, filed, declared consistent with a natural body. Yet the unease persisted, for Oumuamua, too, had been silent. If both objects had been probes, their silence could reflect not absence of intelligence, but the patience of it. What if the true purpose of such visitors was not to announce themselves, but to observe? The fear deepened when scientists recalled Hawking's warnings that advanced civilizations might not wish to reveal themselves, and that contact, if it came, would not be on human terms. A silent probe fits that mold. It needs no dialogue. Its presence alone is the message. And perhaps the message is not for us to hear, but for others of its kind, scattered across the galaxy. For NASA's SETI collaborators, the silence carried philosophical weight. In a universe where natural processes abound, silence is expected. But in a universe alive with intelligence, silence can be unsettling. It may mean that we are surrounded by watchers who have no interest in speaking. It may mean that we are not yet worth the reply. Or it may mean that our instruments are deaf to the true language of the stars. To the public, silence is easily dismissed. Nothing to see, nothing to hear. But for those attuned to the strangeness of 3I Atlas, the absence of a voice was louder than any broadcast. For in silence lies ambiguity, and in ambiguity lies fear. If the object were natural, silence meant nothing. If it were artificial, silence meant intent. Philosophically, silence is as heavy as speech. Humanity often interprets quiet as absence, but in the cosmos, quiet may be the loudest answer of all. 3I Atlas drifted past Earth mute, refusing either to confirm or deny the suspicions it provoked. That muteness became its legacy. Was it the hush of stone or the hush of strategy? And so, the search for signals became less about detection than about reflection. To strain ears at the sky and hear nothing is to be reminded that the cosmos does not answer easily. Sometimes it does not answer at all. But silence, too, is a message. And in the case of 3I Atlas, the message was clear enough. Not every visitor comes to speak. If silence was unsettling, vision offered no greater comfort. For NASA and its global partners, the hope rested on the new generation of observatories, instruments built to see the sky with unprecedented clarity. The James Webb Space Telescope, newly operational, peered into the infrared, capable of detecting faint heat signatures invisible to older eyes. The upcoming Vera-C, Rubin Observatory, with its sweeping sky surveys, promised to catch every transient visitor. Together, they formed humanity's sharpest gaze upon the cosmos. And yet, even under these eyes, 3I Atlas remained elusive, refusing to resolve into certainty. James Webb turned its golden mirrors toward the object, but the challenge was immense. 3I Atlas was small, faint, already receding into distance. Infrared spectra were gathered, but they spoke in riddles, muted signals, hints of carbon compounds, ambiguous traces that neither confirmed nor denied cometary origin. There was no thermal plume to suggest active jets, no glow to reveal hidden ice, only the faint warmth of sunlight reflected from a surface that would not confess its secrets. The Vera Rubin Observatory, still preparing for full survey operations, was hailed as the sentinel of the future. Its wide-field vision would, scientists promised, transform the hunt for interstellar objects. Where Pan-STARRS and Atlas had caught only 3 in a decade, Rubin was expected to find dozens, perhaps hundreds. If 3I Atlas was strange, it would not stand alone. Patterns would emerge. Context would come, yet the promise was of tomorrow, not today. For 3I Atlas itself, the window of observation was closing. This reliance on instruments sharpened both wonder and fear. Humanity had reached the point where it could see across billions of light-years, capturing the birth of galaxies in Webb's gaze, and yet a single shard drifting through its own solar system defied clear interpretation. The irony was bitter. The farthest vistas unfolded easily, but the near intruder mocked every effort at clarity. In the halls of NASA, the tone grew cautious. Official statements emphasized the limits of current data, the promise of future instruments, the need for patience. But beneath the careful language lay frustration. If Webb and Rubin could not resolve such mysteries, what hope was there of confronting visitors even stranger? If the best eyes in history could not see, perhaps the objects themselves were designed not to be seen. Philosophically, the situation became symbolic. Humanity had built telescopes as extensions of its curiosity, believing that sharper vision would always yield deeper truth. 3I Atlas revealed the flaw in that faith. Some mysteries are not limited by instruments, but by the nature of the object itself. To see is not always to understand. The most advanced technology may still face silence, not because it is inadequate, but because the cosmos withholds. And so, the new observatories became not solutions but reminders of limitation. Webb's golden mirrors, Rubin's sweeping surveys, these were humanity's proudest achievements, yet even they could not unmask the visitor. The fear deepened. Perhaps no telescope ever will. Perhaps some questions are meant to remain suspended, the answers drifting away with the object itself, into darkness where no lens can follow. The fleeting passage of 3I Atlas brought with it a recurring frustration. Astronomy can observe, but it cannot pursue. The object hurtled through the solar system, uncatchable, a visitor destined to vanish into the dark. And so, the conversations within NASA shifted from data to dreams of pursuit missions, bold proposals to intercept not only this intruder, but the next. If interstellar objects were becoming a pattern rather than an anomaly, then humanity could no longer afford to stand idle. Concept studies began to circulate. Could a spacecraft be readied in time to chase 3I Atlas before it escaped beyond reach? The calculations were cruel. Its speed was immense, its lead too great. To catch it would require propulsion systems beyond current technology, drives that did not yet exist outside theoretical papers. The dream of pursuit was acknowledged as impossible for this visitor. But the exercise ignited something larger, preparation for the next. Among the ideas was the interstellar probe concept, a mission designed not to follow a specific object, but to leap ahead, waiting in the outer solar system for the next wanderer to appear. Stationed far from Earth, equipped with rapid response thrusters, such a probe could pivot quickly to intercept, gathering close-range data before the opportunity slipped away. Other proposals imagined launch-on-alert missions, spacecraft pre-built and stored, ready to fire the moment a new interstellar path was detected. The logistics were daunting, but the urgency was undeniable. The conversations also turned to propulsion. Chemical rockets were insufficient. Nuclear thermal propulsion, solar sails, or even more exotic drives, fusion concepts, ion thrusters powered by beamed energy, were invoked as the only way to reach speeds sufficient for interception. 3 ATLAS, in this sense, was less a puzzle to be solved than a challenge, daring humanity to extend its reach, to build technologies equal to the mysteries drifting through its skies. The fear threaded through these discussions was practical as much as philosophical. Each interstellar visitor came and went with haunting brevity. Oumuamua, Borisov, Atlas, they had each crossed into awareness and then receded, leaving only fragments of data. Without interception, without direct study, the truth would remain forever ambiguous. To live with that ambiguity was a kind of blindness. How many relics, probes, or exotic shards had already passed unstudied? How many more would be lost to time if humanity failed to act? For NASA's engineers, the pursuit proposals became a mirror of ambition. To chase an interstellar visitor was to confront the limits of current capability, to acknowledge that exploration demands more than curiosity, it demands risk, invention, and resolve. And philosophically, the notion carried deeper resonance. To pursue 3I Atlas, or its successors, would be to step into a new era of exploration. No longer confined to the solar system, humanity would begin to touch the galaxy itself, one visitor at a time. But with ambition came dread, for if one of these objects proved truly artificial, then interception would not be mere observation, it would be contact. And contact, as Hawking warned, may not be safe. The very act of pursuit could transform humanity from passive observer into participant in a drama it does not understand. The boldness of such missions carried with it the weight of responsibility, the risk of awakening something best left unknown. Thus 3I Atlas, even as it fled into darkness, reshaped the future. It forced the question of pursuit, of readiness, of whether humanity will meet the next visitor with eyes only or with outstretched hands. And in that question lay the essence of fear. To chase is to risk, but to remain blind is to accept ignorance. The choice is not between danger and safety, but between danger and silence. Beneath the equations, beyond the technical reports, another question stirred within NASA and its thinkers. What if 3I Atlas is not simply a fragment of the universe, but a reflection of ourselves? For in every observation, in every debate, the object forced humanity to ask what kind of species it wished to be. If the visitor were artificial, a probe of unknown design, then what responsibilities would fall upon us, the ones who discovered it? The thought was unsettling. To ignore the possibility of intelligence was to risk blindness. To declare it prematurely was to risk hysteria. Between those extremes lay a fragile responsibility to seek truth without arrogance, to interpret without projecting too much of ourselves upon the silence of stone. The fear was not only that 3I Atlas might be alien, but that humanity might fail to respond with wisdom if it were. The ethical dilemmas multiplied. If an interstellar visitor is a relic of another civilization, even one long dead, then is it not an artifact of heritage? Would probing or capturing it be exploration or desecration? To study such an object would be to step into the role of archaeologists of the galaxy, inheritors of a past not our own. But archaeology carries responsibility, respect for what is found, humility before what it represents. The silence of 3I Atlas did not absolve humanity of that burden. Even if natural, the questions remained. Should humanity treat such visitors as mere curiosities, or as reminders of the fragile openness of the solar system? If interstellar wanderers can arrive unannounced, then perhaps Earth is not a fortress, but a crossroad. To live at a crossroad requires awareness, preparedness, and humility. NASA's fear was not only of collision or technology, but of neglect that humanity might fail to recognize its role in a larger story unfolding all around it. Philosophically, the reflection deepened into existential territory. If 3I Atlas is natural, it still tells us that planetary systems break apart, that chaos scatters worlds, that survival is never permanent. If artificial, it tells us that intelligence, too, leaves fragments, and that we may one day bequeath our own shards to future skies. In either case, the responsibility is the same: to confront impermanence with awareness. The haunting thought was this: one day, Earth will send its own emissaries into the galaxy. Probes, spacecraft, perhaps even fragments of ruined satellites will wander the stars. They will outlive our species, our civilizations, perhaps even our planet. When another intelligence encounters them, will they be studied as relics of curiosity or as warnings of hubris? Humanity's treatment of 3I Atlas foreshadows how others may treat our own legacy. And so, responsibility entwined with fear. NASA's scientists felt the weight of knowing that their interpretations would shape public understanding, policy, even philosophy. To dismiss too quickly was to bury a possible revelation. To sensationalize was to distort. Their burden was not only to calculate, but to carry the role of guardians of perspective. In this sense, 3I Atlas became a mirror not only of the cosmos, but of us. It asked, how do we respond to the unknown? With fear, with arrogance, with reverence, or with humility? The responsibility to answer wisely is not scientific alone, it is moral, and in that moral weight lay perhaps the deepest reason why NASA feared 3I Atlas. It was not only about what the object was, it was about what we might become in facing it. As the debates unfolded, NASA's laboratories and observatories returned to their instruments, striving to capture every possible trace of information. Telescopes scanned for remnants of the object's trajectory, searching for subtle tails of gas, micron-sized dust grains, or faint chemical fingerprints. Though 3I Atlas had already vanished into the black, data lingered in archived spectra, waiting to be reinterpreted. The task was not glamorous. It was slow, patient work, the kind that stretches across years rather than weeks. Yet, it was the only way to sharpen knowledge. Powerful tools were marshaled. The Hubble Space Telescope, though aged, had given glimpses. Now the James Webb Space Telescope, with its immense infrared sensitivity, was tasked with similar future events. Instruments on Earth, the Pan-STARRS system, the Vera C. Rubin Observatory preparing for its nightly survey of the sky, would watch for other intruders. The goal was simple: to never again be caught unprepared by such a fleeting visitor. Behind the scenes, computer models grew in sophistication. Simulations of galactic dynamics traced the probable paths of rogue objects, offering statistical maps of where the next wanderer might appear. Supercomputers tested scenarios. What if an object's surface contained engineered alloys? What spectral signature would betray it? Could polarization or thermal emission reveal internal structure? These were speculative exercises, but in them, NASA sought to transform fear into readiness. There was also a quieter effort to calibrate instruments so finely that the difference between a natural comet and an engineered probe could be detected, however small. Spectroscopy became a kind of language study, learning to read the subtle dialects of light, where one misplaced absorption line might hint at artificiality. Each upgrade, each calibration, was a step toward piercing the silence of interstellar arrivals. Meanwhile, collaborations deepened. NASA joined with the European Southern Observatory, the Japanese JAXA, and private observatories, weaving a global net of vigilance. For no single agency could claim ownership of the stars. This unity itself was a response to the fear, an acknowledgement that cosmic mysteries belong not to one nation, but to humanity. Ongoing missions added to the arsenal. The OSIRIS-REx spacecraft, once designed to sample an asteroid, provided insight into how surfaces weather in space. Data from these missions offered templates for comparison, what was typical of rock and ice, and what would stand out as alien. Soon, newer missions, equipped with more sensitive detectors, would expand that database. In this way, science moved forward, slow, methodical, imperfect, but relentless. NASA could not command certainty, but it could reduce ignorance. Its fear of Three-Eye Atlas was tempered not by answers, but by the commitment to seek them with better tools. The next time an interstellar wanderer crossed into the solar system, the instruments would be waiting, sharper, hungrier for truth. What remained uncertain was whether truth, when it finally arrived, would comfort or terrify. Science could build the tools, but the meaning, the reflection upon what was found, would still fall upon human imagination. The telescopes would gather light. Humanity would decide what that light meant. The story of Three-Eye Atlas, though unresolved, carried humanity to the threshold of awe. In its silent passage, the object had forced a confrontation with questions that science alone could not settle. Was it natural, a fragment cast adrift from the collapse of some forgotten solar system? Or was it artificial, a shard of engineering older than our history? The uncertainty lingered, a weight both humbling and inspiring. For NASA, the fear was never only about collision, nor purely about the unknown. It was about the vastness of possibility, about being reminded that our solar system is not isolated, but permeable. Objects drift in and out, emissaries from regions our telescopes cannot yet map. Each visitor is a reminder that the universe is restless, its debris, and perhaps its artifacts, slipping quietly through the corridors of space. The philosophical questions became as pressing as the technical ones. If Three-Eye Atlas was natural, then it whispered of destruction elsewhere, planets broken, stars reshaped, chaos scattering fragments across the galaxy. If artificial, it whispered of intelligence older or stranger than ours, leaving traces too subtle for certainty. In both interpretations, humanity stood at the edge of something greater, reminded that knowledge and mystery are inseparable. The scientists who tracked the object, who modeled its orbit, who debated its origins, became part of a lineage. They joined Galileo watching the moons of Jupiter, Herschel sketching nebulae, Einstein bending light with equations. All had faced mysteries too vast to solve in their lifetimes, yet each added a thread to the fabric of human understanding. Three-Eye Atlas became one such thread, unfinished, enigmatic, but enduring. And so, the close was not closure. The object itself receded into the darkness, beyond the reach of telescopes, beyond the whispers of speculation. What remained was its imprint on the human spirit, the reminder that fear and wonder are intertwined, that to explore the universe is to risk unsettling discoveries. In fearing Three-Eye Atlas, NASA revealed not weakness, but humility, the recognition that some truths arrive only slowly, through patience, vigilance, and imagination. The cosmos will send more visitors. Each will demand vigilance, caution, reverence. Each will sharpen our tools and deepen our questions. Humanity's responsibility will be the same, to listen, to learn, to face the unknown with both courage and care. Three-Eye Atlas was not the last, nor the first. It was simply the one that taught us to pay attention. Now, as the narrative draws to a close, the pace slows, and the voices of inquiry soften into silence. Imagine the object, Three-Eye Atlas, vanishing into the deep, its trail of dust dissolving into starlight. The fear that once stirred so sharply begins to dissolve too, replaced by something gentler, a recognition that the universe is vast and that our role is to listen more than to command. The telescopes rest, their mirrors cooling beneath the night sky. The equations pause on chalkboards, waiting for new hands to continue the work. Even the debates that once filled lecture halls fade into a quiet hum. What remains is the stillness of the cosmos, infinite and patient. You might picture the galaxy itself breathing slowly, its stars drifting in patterns that span eons. The interstellar objects, whether stone or artifact, glide along those currents like leaves upon a river. They are reminders that time is not measured in hours or centuries, but in millennia, in the lifetimes of stars themselves. Against that scale, human fear feels smaller, softened, almost tender. And in that tenderness lies comfort. Whatever 3i Atlas truly was, it has already passed beyond reach, leaving us with curiosity instead of answers. That is not defeat. It is a gift, the chance to wonder, to stretch thought beyond the horizon of certainty. So let the questions linger. Let the silence of the stars settle gently. Sleep, knowing that the mysteries of the cosmos will still be there when you wake. The universe is patient, and so may we be as well. Sweet dreams,